This is lesson 4, unit rate as the constant of proportionality. Proportional relationships have a constant ratio or unit rate, and these are points to remember. The constant ratio or unit rate can also be called the constant of proportionality. The first example is the National Forest deer population in danger. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16-mile area of the forest. Another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square plot of the forest. Do conservationists need to be worried? What is the population density of deer per square mile? So in other words, we are going to find the unit rate. So the first thing we do is find 144 divided by 16. And again, let me get my calculator. So we have 144 divided by 16. And here we have 9. Then we have 117 divided by 13. That also equals 9. And then we have 216 and that also equals 9. Because all of these ratios simplify to the same number, that is a proportion, and our unit rate right here is 9. Our constant of proportionality is 9 over 1, which equals 9. And to explain this, remove that. To explain the meaning of the constant of proportionality in this problem, that means that there are 9 deer for every 1 square mile of forest. It says write the equation to represent this relationship. Well, remember our general equation is y equals kx. We're going to replace the k, which is our constant of proportionality, so it would be y equals 9x. B says, use the unit rate of deer per square mile, or y over x, to determine how many deer there are for every 207 miles. Well, here, what we would do is we would multiply that unit rate of 9 of 207 times 9, which would give us 1,863 . deer. C says use the unit rate to determine the number of square miles in which you would find 800 or 486 deers. Well, 486 divided by 9 that would be 54. 54 square miles. Okay, so next. Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire 8th grade level. For his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needs cookies the very next day. Brandon and his mother determined that they could fit 36 cookies in 2 cookie sheets. Is the number of cookies proportional to the number of cookie sheets used in baking? Create a table that shows data for the number of cookie sheets for the total number of cookies baked. Now remember what we talked about when creating a table for the independent and dependent value. Sheets are the independent because you can have cookie sheets and not do anything with them. So these are our cookie sheets, and these are our cookies. So for every 2 cookie sheets, we have 36 cookies. So if I use my y over x, which is 36 over 2, and I divide that, I get 18 over 1, which is my unit rate. So I have 1 cookie sheet will make 18 cookies. So if I continue this, we have to remember we have 3 cookies for each of our 96 students. So let's find out how many cookies we actually need. So 96 times 3 is 288 cookies. So now if I have 4 cookie sheets, I have 72 cookies. I have 6 cookie sheets. I have 108. I have 8 cookie sheets. I have 144. And if I double that, if I multiply that by 2, I get 16, and I get 288, which is what I need. So my unit rate, we keep going, my unit rate is 18. So my constant of proportionality is 18 over 1, which is 18. And what that means in this problem is I have 18 cookies for every 1 cookie sheet. To write an equation would be y equals 18x. So then it says it takes 2 hours to bake 8 sheets of cookies. If Brandon and his mother begin baking at 4 p.m., when will they finish baking the cookies? Well, if we notice up here, 8 cookie sheets will make 144 cookies. So at 4 p.m., to 6 p.m., it's 2 hours. They will make 144 cookies. From 6 p.m. to 8 p.m., is another 2 hours. When I add that, that's 288 cookies, which is what we need. So Brandon's mother will finish at 8 o'clock. Now, example 3, Suzette and Margot want to prepare crepes for all of the students in their French class. A recipe makes 20 crepes with a certain amount of flour, milk, and 2 eggs. The girls already know that they have plenty of flour and milk to make 50 crepes. They will need to determine the number of eggs they will need for the recipe because they are not sure they have enough. Considering the amount of eggs necessary to make the crepes, what is the constant of proportionality? We can make 20 crepes with 2 eggs. So when we divide that, 20 divided by 2 equals 10 over 1. So 10 over 1, excuse me, is our constant of proportionality. So 10 is the constant of proportionality. What does the constant of proportionality mean? Well, it means that they can make 10 crepes with 1 egg. Now the next question says, how many eggs are needed to make 50 crepes? Well, taking the 50 crepes and our constant of proportionality, we can divide that. 50 divided by 10 means that it would take 5 eggs to make 50 crepes. So now, to sum it up, what is another name for constant that relates the measure of 2 quantities? Proportional relationship. How is the constant of proportionality related to the unit rate? They are the same. And that's the end of the lesson.